Hello everyone, welcome back to MAT052. In this little lecture, I'm going to go over hypothesis tests, basically some operations. We're going to continue on. I'll make sure that hopefully to fill in any blanks that we've got up to this point. Okay, so here is basically the foundation of hypothesis testing. Okay, so I'm going to kind of scribble this up here. Remember, we need some kind of claim. Okay. Come on. Claim. And that would be, let's say if we're talking about the mean, and it would be something like the mean is equal to 25. I just know that the mean is equal to 25. So you made a claim. Okay, so what we're going to do is we're going to start out with that statement, and then we're going to do a complement. Complement. So the complement for this would be mu not equal to 25. Okay, so we would do it our assignments, H0, that's our null hypothesis, and then the alternate would be the one that didn't have the equal. Even though that's got this equal, this is not equal, and that's the same thing as less than or greater than. That would be a two-tailed test. Okay, so we'll have complement pairs. So if it was something about, let's just do everyone with the mean, and the proportion would be the very same. So I said the mean is greater than, let's go some number. The complement pair would be mu less than or equal to that number. If mu is less than a number, mu less than 15, mu less than 25, the complement would be mu greater than or equal to that number. What about if I have a statement mu greater than or equal to n, mu less than n? Mu greater than or equal to n, the pair would be mu, I got the same one, less than n for this one, and that would be mu greater than n. Okay, and then finally, I could have mu equal to n. The complement would be not equal. This would be the same as less than or greater. And then it could be that it's not equal to n, and then we would just use mu equal to n. So these are the complement pairs. You would just go pick out one, and then that would give you, if we did the assignments, then this would be H0. Here would be H0, H0. This would be HA, HA, H0, H0, HA, H0, HA, H0, HA, H0, and HA. Okay, so once we get that, we look at this, you know, what kind of test are we going to do, and we look at the complement, the HA, to give us what type of test. So it could be like mu less than n, that would be a left tail test. Mu greater than n would be a right tail test, and then the mu not equal to n would be a two tail test. Okay, so what we do is we pick this up, and then we're basically going to say, well, give me a sample. We're trying to prove or disprove either one of these hopefully is going to be just true. Sometimes we can't disprove it, or we can't prove it, and we just have to fail to reject the possibility that it's true. Okay, but how we're going to do that is go get a sample. So once we have this, we set up a test. For example, if I had this one, I have a two-tail test. Right here would be in the middle, that would be that mu equal to 25. And then I would go get a sample, a statistic value that is a test value. So this is the test statistic. Statistics comes from samples, so I'm going to go grab a sample value that I'm going to use as a test. That's just the test statistic. And then I'm going to compute the z-score or t-score. And I'm going to go out here and I'm going to plot this thing and find out where it is. If it's too far into these tails, I would reject. So the tails are the rejection regions, and the inside is the fail to reject, FTRF, fail to reject, okay? But this is, depending on what we're doing, What kind of test? Is it for the mean? Is it for the proportion? Do we know something about sigma? All of these test statistic values, the scores, is going to be based on what things we're looking for, the mean or the proportion, the difference between. All of these have their own little test statistic formula, okay? So let's go through this thing. So the formula for the test statistic and a hypothesis test for a population mean, where the population standard deviation is not known. So if it's known, I'm going to do something a little different here. I'm going to do a z-score, and this is going to be the population standard deviation. Okay. Recall then a fraction that are their implied grouping symbols. Do everything in the top, do everything in the bottom, and then divide the bottom into the top. Okay, so do all of that first, do all of that second, and then do the division. And if you do everything at one time on your calculator, make sure you put parentheses around there, or it'll just be like x bar minus this division, and then do that division, and then finally stick that in with x bar. And it's not what you want. You want to do all of this, and then divide that into that. Okay. So here's the value. Here's the formula for test statistic for population mean, sigma unknown. Is the x bar from the sample. The mu0 is from H0, the H0 value, the mu0, whatever that value is. You know, mu less than mu0, whatever that number, you're going to put that in there. That's what they have claimed, that this is the number. And they made the statement, so we're going to hold them to it. Okay. So I'm just going to step through a couple of these examples. The mean value for a sample of 60 homes per cell in Nashville, Tennessee was x bar. That's from the sample of n equal to 60. There's your x bar with a standard deviation of s is equal to 7,400. That is the sample standard deviation, not this population sigma. A hypothesis test will be performed to determine whether the mean home value differs from mu0 is equal to 220,000. Find the test statistic. So we're just going to go with these. We're just going to use the test statistic formula they've got. We've already got this because we don't know what sigma is, so we're going to use this thing. I need x bar. There it is, the sample mean. The mu0, that's from the claim. So here was, we need a hypothesis test to determine whether the mean home differs. So this is the claim. Does mu0 not equal 220,000? Okay. That's basically versus mu0 equal to 220,000. H0, HA. Okay, and this would be a two-tail test if we worked here. Okay, sample standard deviation, sample size, and then we set this thing up. We'll spend more of that in class of setting the whole thing up, but we just want to work on doing this test statistics. So now I've got everything I need. Here's my sample mean minus the hypothesized value, the 220,000. That's one that's this from the statement. I do this calculation first. Now notice that this is less than this. This will be a negative value, right? If it's bigger than that, it's going to be a positive value. And then here I do this calculation, 7,400 divided by the square root of 60. That gives me that. And then I do the calculation here. I just don't want to run a string of numbers together and expect the calculator to know that I want to do this or this, okay? So the test statistic, t is negative 1.15. And so if I went in here and kind of plotted, I'll plot this thing out to the side. I had a two-tailed test. Here is 0 now because, you know, from everything, whatever value, alpha over 2 because it's a two-tailed test. And then we would plot this out here. Let's say 1 is here. So in here is negative 1.15. And whatever value of that test, I'm going to come up with the test critical values. Okay. Over here, less than the negative 1.5, we would reject. This is rejection regions in the tail, and fail to reject here. So I'm pretty sure that we would fail to reject, and who are we failing to reject? Always H0. Okay. So then we would go back up and see which one is the claim. So we would fail to reject that it was possibly 220,000. So we cannot support, there's insufficient evidence to support the possibility that they differ. Those are the ones that we really can't tell. We just don't have enough data, information. For proportion, if I do a hypothesis test for population proportion, I do the very same thing. I give a statement, complement, assign H0, H1. HA, the H1, that tells us if I'm a left tail test, a right tail test, or two tail test. And then I go get a sample. The P hat is from the sample. That's the sample proportion. And the test statistic, what I'm going to compare in my little graph, what region, that's the value from here. And if it's too far away from the hypothesized, this is the hypothesized proportion. This is from the statement, P less than P0. Like P less than 0.15, this would be P0. Okay. So in a survey, let's take a look at this. In a survey of 140 adults, 45 of them had tried virtual reality technology. Proportion, right, from last time. Hypothesis test we performed to determine whether more than 30% of adults, again proportion, have tried the technology. Find the test statistic. So we would go through the statement. Let's add the statement. So I would need a P, so later on. So here's the thing. To determine whether more than 30, so P greater than 0.30. Complement, P less than or equal to 0.30. I need to put a claim here. H0 would be here, HA without, and this would be a right tail at points to the right, so right tail test. So if I drew the little picture here, anything in here I'm going to reject, that's my rejection region. Anything out here I'm going to fail to reject. And my hypothesized value, this is going to be 0 when I put all the test statistic, but this is basically the 0.30 point. Okay. My P hat, that's just X over N. Sample size, 140 adults in a survey or sample size, 140. 45 of them had tried virtual reality, technology. Okay. So once we do that, we calculate our P hat. That's the 45 over 140.3214. And then I just do, now what was the hypothesized? P0 was from the hypothesis side. That would be the 0.30 before we ever get down there. I want to show you too. So here's the formula, and this is a z-score. So we would go, when we compare anything and do critical values based on an alpha, which we haven't worked on with yet, this would be a z-table that we went to, so A.2. The t-test would have been the A.3, okay? 0.3214, that's our p-hat. P0 is 0.30. P-hat, 1 minus p-hat over 140. Now this is how we need to do. I need to do all of this, put that number. I need to do all of this, put that inside underneath the radical. So I need to do all that here first, 0.30, 1 minus 0.30, divided by 140, write that under there, take the square root, and then I do the top divided by the bottom, okay? Not just, at any order in here. It needs to be, everything needs to be cleared up top. Underneath the radical, top, bottom again, do the division, then take the square root, and then do our z, okay? So here again, The way we would work this thing, this was a right tail test. Right tail test. The right tail test, that's the claim. And once we did this, we would do it at some alpha value. Rejection region, fail to reject. And notice that 0.55 of the test statistic is probably going to be in here again, unless we got a really weak alpha. It's going to be in here, and we're going to fail to reject H0. So it's still possible with that sample that we took that it would be, it's a possibility that it could be less than or equal to 0.30. Even though the p-hat was bigger, it was close enough that we couldn't reject this possibility that the real population proportion was less than or equal to 0.30. Okay, so go through, step these things out. It's giving you a little bit. Here's the things, and then do the test statistic. Just make sure you do everything, calculate top, bottom, and then do the overall top, bottom in there. Okay, and I'll see you next time. Have a good week.